KVA, or kilovolt amps, measures apparent power. Apparent power includes both real power and reactive power. It's calculated by multiplying voltage and current. Kilowatts, abbreviated as kW, measures real power. Real power is the power that performs useful work. It's calculated by multiplying voltage and current, and then multiplying that product by the power factor. Power factor is the ratio of real power to apparent power. It's a value ranging from 0 to 1. A power factor of 1 means all the power is real power. A power factor of 0 indicates all the power is reactive power. When calculating residential loads, considering the power factor of appliances and equipment is important. Firstly, KVA determines the size of wiring and transformers needed. The KVA rating of a circuit or transformer must be sufficient to handle the apparent power demand. If the KVA rating is too low, overheating and potential electrical hazards can result. Secondly, kilowatts determines the actual power consumption. The kilowatt rating indicates the amount of energy actually being used. This is important for billing purposes and for determining energy efficiency. As an example, consider a residential circuit using a 240 volts appliance with a power factor of 0.8. If the appliance draws 10 amps of current, then the apparent power in KVA is calculated as voltage times current, which equals 240 volts times 10 amps, resulting in 2.4 kVA. The real power in kilowatts is calculated as apparent power times the power factor, which equals 2.4 kVA times 0.8, resulting in 1.92 kilowatts. This means the circuit must handle 2.4 kVA of apparent power, and the appliance consumes 1.92 kilowatts of real power. Understanding the difference between KVA and kilowatts is crucial for accurate load calculations in residential settings. It ensures that proper wiring and transformers are used to meet power demands, while also accounting for the power factor of appliances.